Hello, my name is Charles Tan. I'm an engineer by education and in electrical and electronic engineering. I've been accredited a professional engineer by Engineers Australia. With this accreditation, I can actually provide assessment to other field of engineering. I'm going to introduce my solutioning towards climate change, fuel and food security, and I'm the inventor of the sweet potato growing pot. So we know that the earth is in crisis. It's going to get worse. The sea level are rising with and then with the rise in temperature due to the carbon dioxide in the atmosphere, and there is an increase in intensity of twisters around the world, uneven distribution of rain, so displacement of people right now. So eventually you will involve even food scarcity. Fossil fuel as we know it will run out, so will coal and fracking as well. There will be nothing left for our children to deal with all these crises. So I migrated to Australia on a state-sponsored visa. I'm here to retire. I retired as a military officer from the Singapore Armed Forces. So I bought the farmland in York. And I saw the process of farming. And there was a weather change about 3 years ago, but then it was hot and few rain. But now we got a bit more, it's getting a bit more wet, and the eastern states has got a bit more dry. So I knew that when I saw the way they farm, yes, we had to go it organic. And I found ways to grow trees that uses firstly less water. And so by accident, a mix of sweet potato in the pots itself actually fertilize the tree and result in organic produce. So then I focused on just sweet potato alone, and that resulted in the vertical structure. So I can see in the background it's a pot, and all you need to do is to retain a certain like 20% to 30% of the total height of the pot, and that itself can result in about 5 to 7 times water saving. How much is it? Is that in the summer, with these features, you only need to water once every 2 to 3 days and about 40 to 60 seconds. So this photo is taken in the winter. So if you keep the sweet potato inside, you put enough nutrients for it to create a nice foliage, as you can see right here. And so if you cut it, you put it on the ground and it will grow, and within 6 months you get a clutch of sweet potato. So for this particular one, this is 4 kg, but this part here has been eaten off by rodent, and I didn't manage to get it out perfectly. So this could have been a 4.5 kg sweet potato. So this is my invention, and I managed to bring all the vines in my house to the farm, and again it's grown on pots, drums, and this is, and you do not need the whole drums. This is 1 meter, and so the water is actually tap off from halfway through. But if you only need the top part, and you get all the top part and you stack them up this way, you can have a vertical structure. This is the result of the vertical structure. So this was planted in spring last year, 1/8, both sides. And soon after I planted, the locusts came as always. And I know that if the locusts were to eat it, they will die at the same time. But it was in a swarm, So it emptied up almost the back there. But in autumn, it came up nicely all by itself. So it's very resilient towards pests. It actually kills locusts so the birds and other predator insects like ants, praying mantis, all leash around here, and it's all organic. It's just mulch, sheep poo. So this is the result of it in autumn on both sides, and this is in winter. We just came out from winter, and it did suffer a bit because there was many days of frost, but it's coming up nicely now. So it also suffered a bit during the hot summer, but it's a very resilient crop that can be grown organically, and it can yield very good large sweet potato. You do not need to grow them in mulch. You can actually do that in water, and you can see here, this is actually grown just in water. There's nothing in there, but you have to keep the water at a certain level so that its roots can always be wet. So this is in March, and this also just came out in the winter. So this is my patent, and it actually has the top half and the bottom half. The top half and the bottom half. So it just really come together, and it forms 3 container. All right, it comes together, it forms 2.5 container. So 3, 2.5, 3, 2.5, and then just continue upwards. So and you can, and to harvest it, you just unlatch it, and you just fall down by gravity, and this is how you harvest a sweet potato. There is a spring here at the bottom, which you can weigh the whole thing, and so if it exceeded a certain weight, it's time to harvest, or because the sweet potato, when it grows, it exerts actually 9 tons of pressure in all directions, so you have to allow it to expand. So which is why it only rests, this comes together as covering on top of each other, and that will result, when the sweet potato grows, it will just expand itself. So the expansion will be uneven, but it will go up. So by telling how much is being displaced, it should tell you that is it time to harvest or not. And so the good thing about now is that there is an elevation here, which minimize the chance of rodents and pests from able to breach it and get into the pots, the containers. And for this case, it's also drought and flood resistance. So again, if you just take out the whole thing by itself, this is the front, it has a cover to prevent rodent from going in. So this is where you put the vines. You put the vines in. You put the vines in, and you cover it with mulch. And then you put the cover through the cover, okay, and then this is all rest up, and you just water it. So this is the back of it. If there's excess water, it just flow out from the hose, and there's a certain amount of water that's retained in it. So you have been granted an Australian patent, and have successfully lodged international patent through a patent office of Sullivan. My farm in York is 415 acres, 100 kilometers from Perth. Each hectare is able to contain right now an estimate of 650 pots. So there is a total of 5 hectares land allocated here. So the height right now, it will be 5 meters, and in the end, the width and the length, which is the same, is about 1 meter to 1.5. So in this farmland, the bioethanol refinery, the prototype for it will be built together with the prototype for a biodigester. I call it a cold model. The cold model, by the word mean, is that when you touch the surface of the digester itself is cold. It's about 20 degrees, and it will generate electricity and heat. So it does away with the fermentation tank, and it uses internal energy. So it's least efficient, but we are talking about gigaliters of mulch to process. So we are not so concerned about how much efficient it is. We need to get the mulch done and over with. Okay, so and we are going to push gigaliters of mulch through it. So we cannot afford the expensive fermentation tank, which takes about 3 months. And we can sustain cows and sheep because the sweet potato itself, the whole plant can be consumed. And the result of the biodigester is actually, other than energy, electricity and heat, it will generate worms. So this is where the pots will be placed, this pot. So I normalize the 1 hectare land, 650 pots per hectare is able to produce 1.6 tons of sweet potato. And the price is $800 per ton, and this is a market price. So by virtue of the sweet potato alone, the revenue is 1.3 million. It is able to produce bioethanol at 160 kiloliters as a result, able to sustain 320 animals per hectare per year. 4 tons of biomass, we generate electricity of 0.16 megawatts and heat 0.176 mega in heat, absorption of carbon by 570 tons. And of which case, the result of this itself will generate feedstocks, and that essentially can convert up to 30% of the biomass. So for 5 hectares land, this is actually what it is. And the water needed is 13 million liters per hectare per year, total 65 million liters per year. And this is a good thing actually, and I'll tell you why. So there's only 2 solutions for me. One is to use reverse osmosis, which is not possible because I'm way off the ocean. Plateau effect is the only way for me to go, and I can use 40 watts to make 1 liter of water per hour in the most humid condition. So this is a plateau effect. One end is hot, and when you put electricity in, and you do away the heat, the other end is cold, and you allow condensation to happen, and water will just be generated. Normalizing to 1 hectare, continuing, the 5 hectares land in total will get 800 kiloliters of bioethanol, almost 1 megawatts of electricity and 1 megawatts of heat. So the plateau effect, I only use up all this energy up to 110 days to generate enough water for the whole plantation, the 5 hectares land. So with reverse osmosis, with this amount, I can have 65 million liters of water within a day. And for the rest of the 365 days, I can use it to plug into grid. So after we normalize to 1 hectare, we can now normalize to 1 million. The revenue for the sweet potato alone is 520 billion per year. And we have to take time for it to grow. So let's take that the revenue can only be realized after 3 years. So the bioethanol production is 64 billion liters per year, able to sustain 133 million animals. So the biomass is at 1.7 billion tons per year, generating 64 gigawatts, 71 gigawatts in heat, and 230 million tons of carbon absorption. So of course, again, we will have feedstock for aquaculture and poultry as a form of worms. Australia consumes 1.2 million liters of oil per day, 90 billion liters of oil per year. So assuming that these figures is actually estimated, it's gross, so but give and take, we just actually require only 1 million acres of land to power the whole of Australia. If not, just add a few more. And this will result in a sustainable fuel source for the country as well as food. The ocean will be less of 526 billion liters of water per year once 1 million acres of land is realized in the WA. The expenditure per pot right now is that I have to keep this pot at 3,000, and it has a lifespan of 30 years. A harvester is fully automated, and I can assure this because my major is in control engineering, digital robotics, as well as power engineering. So automating one of these harvesters to go through the pots to harvest the sweet potato and together it can be automated. So maintenance, refinery, estimate at 100 million, reverse osmosis 100 million, biodigester 200 million, operating costs at 30 million, and labor cost is usually at 9 billion per year. So because of the difference in their lifespans, we have to normalize them again to 1 year of a million acre, and this is the result. The revenue then for the first year will be lost, second year will be lost, third year then we realize this revenue of the sweet potato alone, and it will result in 440 billion before tax, and thereafter 520 billion for the next 10 years for the subsequent until you reach year 10, before we have to do some replacement to some of the infrastructure. But you won't make money because you are planting, and you're planting it organically. So when we talk about, we cannot just talk about revenue, we are talking about how they do take some time to grow, because this is plant like all solar panels, you take time to install, like wind turbines, you take time to install. So this also takes time to grow, but this will grow within 6 months. For the drums, to provide enough seedings into the 15 acres land, okay, this can be done within a year to a year and a half. All right, so with this 15 acres land, you provide enough seeding to the 5 hectares land, and from this 5 hectares land, you provide enough seeding cuttings to the 2,000 hectares land in the station of a million acres. And once a million acres is reached, it can supply enough seedings for the other 3 million acres of land the following year, and subsequently, and not forgetting that there's already 1 million, so total 4 million. The subsequent years you'll be 12 million times 3, so it's 4 8 12. So the seeding itself is in an exponential multiplication. Okay. So again, into the 15 acres land from the drums by 2020, into the 5 hectares land by 2022, and for the 5 hectares land, you can jump into the 2,000 hectares land of a station by 2024, and a complete whole seeding of a million acres land by 2026. So if we keep expanding, by 2030, every country will have 3 million of acres of sweet potato. To control the ocean against sea level rise and ice age, we will need another 50,000 million acres. And we can do this, we can achieve this within 10 years, from 2030 onwards. And this has to be rigged in the ocean. We have to trap it, we can use it to trap the rubbish at the same time. So, and why is it an ocean? We can appropriately place it to offset the pressure systems that will disturb the rise of the twisters. So in summary, we are having a climate change due to global warming. The sea levels are rising, the fossil fuel are diminishing, and the food will eventually get scarce. If all the countries of the world were to plant 3 million of acres right now today, you wouldn't absorb this much of ocean water. So, but because of the emission of the carbon dioxide, we can expect that the Earth will be underwater eventually. 3 million acres of sweet potato ensure that all the countries has enough energy and food to ride through the disaster that we have created for our children. Carbon dioxide removal worldwide participation for all this is just 133 billion tons of CO2 annually. However, the need now is also to control the ocean. So if you're going to rig this one into the ocean, we need between 10,000 to 50,000 million acres, and this will actually use up enough water that translates to the drop of sea level, okay, up to 1.2 meters to 6.4 meters lower in sea level if you were to get it to 50,000 million acres. And this can actually be achieved by 2050. And how can we achieve this? Is because along the way we will find ways to do this productively through carbon fiber, because carbon fiber will be part of the byproducts that come out from the biodigester. And then we can think of ways to 3D print it, like print it in 1 second, every port. But so long as there's a need, we can think about it. To bring CO2 to pre-industrial level of 270 parts per million, we need to reduce the CO2 level now by 137 parts per million. So assuming we have 50,000 million acres already in the ocean, which are drawing out CO2, you only translate to 0.295 parts per million of carbon absorption, or 1.472 parts per million respectively. Okay, so to remove this, so that we can get back to the pre-industrial level, we will need, this will then translate to 465 years, or 93 years if we have 50,000 million acres of sweet potato growing right now. However, it just gives you the hope that this can actually be done. We can recover Earth by the end of the century. Okay, if we do not able to recover, but we will know how much more is actually needed. Okay, just to put it qualitatively, if we grow the sweet potato on the vertical structure, we can have a high yield per the same amount of land. So this will then provide food for all of us and for the creatures as well. So as we eat, the thing that we get rid of will provide us with the fuel and energy in terms of electricity and heat. So the more we eat, the more we get this. So but of course you can't eat it quick enough. So because of our industrialization, because of urbanization, we have many high-tech devices in the house. So we have to get every other creatures like cow, sheep, worms, insects, whatever, help us to chew on this one. Okay, and that will give us enough. So the more we eat, the more we get, and the more we get for raw materials as well, carbon fiber. Okay, which is then can be an alternative to plastics. We can make utensils, pots, even mold the casings of equipment into this using carbon fiber. Right, cars right now we have carbon fiber for our race cars and stuff like that. But you get so cheap that we can even use it for daily use, and you can result in organic, environmental friendly usage. Even buildings, even scientists right now think that you can build a skyscraper within like what, a few days, reaching up to the sky using carbon fiber. Then we can help to absorb the carbon dioxide from the atmosphere and help Earth to recover by the end of centuries. So this method will also help special economies of each country independently. You don't have to fight for food anymore. You don't have to fight for good land. Okay, the ocean itself will provide for the countries that cannot grow sweet potato. So if we act now, we can mitigate sea rise and hopefully prevent an ice age. So once the sea level has risen to a certain age, you will tip it, and that will result in ice age. So there is still time. Yes, I will need support for these projects to kickstart in my farm in York, and that will result in new technology. We will now be able to engage professionals, scientists, engineers, technologists into farming. And the proof of concept will be that I'll be able to plug into the grid, and I can actually achieve it if I have the resources by next year. If not, add another half a year. So within a year to a year and a half, I can actually plug the thing into the grid. So alone, the amount of income that generates from my land, 450 acres, will be enough to expand into 1 million acres of land in WA. So very much, I would appreciate your interest, expression of interest. Please write to this email. Buy a space for climate change. Thank you very much for listening. You have a nice day.